idea is probably after the lecture, we'll have a little break, yes, for coffee or to grab a cup of tea, perhaps 5-10 minutes, and then we go back to start working on the first practical. Okay, so yeah, let me start with the introductory lecture. Yeah. Okay. So can I see my screen?
Yes, very well.
Okay, great. Okay, so yeah. Okay, so very quickly, because it's something that has been introduced by Adela, probably you are aware of. So the point of this course, this course is organized in 6 days. So the first 4 days will be focusing on getting acquainted of some basics of GIS, how to handle spatial data in a GIS framework, and basically to help us understand, the spatial distribution of health problems or health outcomes. So we will be working with open source GIS software. So we'll make you, we'll let you work independently after this course. So the point is that you learn how to generate your maps, how to handle your data in a GIS framework, and start exploring for a spatial relationship in the data that you are using or loading in your GIS framework. So you will be provided with the basic tools and the skills to manage spatial data and to start running some exploratory analysis. So as I say, so we will be using open source software. So we'll be working with QGIS, probably one of the, there are many software in the market. We have like proprietary software, which is very powerful, such as ArcGIS. Probably you sometimes have heard of this software, but it's really expensive. But we also have, some platforms which are very powerful, such as the QGIS. QGIS has also the advantage that is allowed for developers to generate new tools. So then as it's an open source software, there are many developers all over the world just developing new patches, new applications that can be adding to the core of the QGIS. Then in this course, you will learn, the principle of GIS, how to use a spatial data set, a spatial feature, how to create maps, how to import your epidemiological data into GIS projects, how to generate maps with this data, and how to run interactions and explore, relationships with your data, with other data sets that you can use in your data set. You will learn how to manage data tables in this environment, and as I say, run some spatial analysis. So another bit for the 4th day is I will give you a lecture on different sources of spatial data. So then currently there is a wealth of sources of spatial data sets in the market out there which are freely available. This is something that didn't happen like 20 years ago. Back in time, we had to generate our spatial data, and we still have to create our spatial data. But fortunately, so when we need, cartography for our countries or environmental data, there are many resources where we can look at and retrieve data for our projects. So then I will give you an entire lecture on different sources, and we'll run a practical around how to retrieve data from different websites and how to use this data for your project. Even today, probably at the end of the practical, I will show you a website where you can retrieve cartography and basic spatial data for your countries, so that you can start running the practicals with your own data set in your own time, okay, after the practical. When it comes to find a definition about what GIS is, it's not easy. So you can look at you can Google GIS and find many different types of definitions. What is probably important for you to know is GIS is not simply a software. It's a combination, of hardware. Obviously, we need to have the computer capabilities to run the GIS software. We need to have the powerful GIS software that allow us to manage and handle the spatial data. And obviously, we need the data. But also, the way we are interacting with the data, these links that we are doing in this GIS environment between a spatial data set is part of the GIS framework. So then, as you see in this graph, so we have hardware, we have the spatial data, digital data in many cases, or data that has been collected through satellite or remote sensing, and we have the software. So then all together, basically comprise the GIS. But you need to understand that for developing geographical analysis, we actually don't need a software. Obviously, it's really useful to have a software because allow us to be more efficient when running analysis. Obviously, in nowadays it's hard just to do something without a computer. But back in time, the first examples of the use of a spatial analysis of the geographical analysis is this one from a cholera outbreak that was studied by John Snow. Those that are working in spatial epidemiology consider John Snow, this British physician, we consider him like the father of the spatial epidemiology. He was the first one just to plot cases of cholera outbreaks in a map. He used like a very simple map of the Soho area and tried just to put every case of cholera in the map. And he also happened to plot, the pipes, the water pipes that were located in the Soho area, and identify, the pipes, the source of waters that were associated with the cholera outbreak. I mean, it's a very basic application of a spatial epidemiology, but as long as this physician was had the thinking of plotting in the map, the cases, and even the intensity of the number of cases, and try just to associate this with sanitation. I mean, it's like is the basic or the principle of a spatial epidemiology. Those that are working on a spatial epidemiology, so we basically try just to find the association of the health events with many other factors that are spatially related with. But as I say, the software simply allows us to be more efficient in our work. That's the other thing. What we do in a GIS framework or environment, so basically we try to represent what is complex and what we see in the real world. So and that's the way that we are working with a spatial feature or a spatial data set. So then, for example, I'm just looking through my window and I see buildings around. So that these buildings can be represented in a GIS framework, so that they can be represented of many ways. So I can have like the coordinate, the position of these buildings, and plot them in a map. So then, basically with this, what we are trying to do is generate a simulation or a representation of our world, so that we can have like a small world in our computer, so then we can explore, how the different features are interacting with each other. Obviously, we are interested to explore, health-related interactions, but the GIS is used for many purposes. So we have the GIS mostly in everything we are doing in our life. So then the power companies, the sewage companies, the network companies, everyone is using GIS, basically to understand and to represent what we can, see in the real world. So another important thing you need to understand is how we work in a GIS environment. So basically, what we are trying just to generate layers. So every type of feature in this GIS environment is related to one feature in the real world. For example, if I want to represent rivers, I will have a layer with the rivers in in my study area or in the area of interest. So for example, if I'm working in Ukraine or Moldavia, I will be interested in getting the river stream waves, a layer with the river stream waves to use in my map. So then if I want to have the district boundaries, I will get another layer with the district boundary. And this is why we are making up or constructing our GIS project, which basically the principle is to have a representation of this complex world. Let's see this with this example. As I explained before, so the way we are creating a GIS is, overlapping layers. So we are overlaying layers. For example, we want to generate a base map, basically. So we want to place ourselves in our study area. And for this, we are using like basic spatial data. For example, administrative boundaries. We are using river, lines. We are using the road network. We are using the water bodies. And, in this way, we are generating, our base map. For, as I say, road network, hydrography. We can have also data concerning to the type of uses we are doing to the ground, to the earth. If we have vegetation, or we have urban areas, or we have forests, or we have croplands, this is the kind of thing we can have. And in the right-hand side, you can see an example of a base map where we have rivers, we have points for the village, we have water bodies. This map corresponds to western of Kenya. And that's an important thing that you need to understand when making a map. Just looking at the map needs to be, self-explanatory. So when I look in a first glance at the map, I can easily understand what the map is showing, what is displaying. So when I'm looking at the legend, the legend is providing some insights or adding information, but just looking at the map, I can understand the water bodies are represented in blue, the rivers in blue. The other lines, they may be, administrative boundaries, but also roads. And this is basically supported by the layer. So what type of data we are handling in a GIS environment? So then basically we have like two major types of data. We have vector data and we have raster data. So then first, I will explain what vector data is. So vector data basically is features which are related to points. Okay, so then we have three types. We have point features, we have line features, and we have polygon features. As you can see, the foundation of all these vector data is the point. Okay, and in GIS framework, a point is basically a position in the space. Okay, so that a point is represented in the real world, but a place. Okay, So then, for example, and this place, as we will see later, is given by geographical coordinates, by coordinates, latitude and longitude, X and Y. So I will explain the difference. But basically, this is the basic of vector data, point. So the point only represents positions in the space. See, we don't have length nor area. It's simply a point. A point can be used to represent city, to represent household, to represent village, basically to represent even, it's represented where we are living. So then if you look at a map from your country, so then your position using a GPS is provided in terms of latitude and longitude. And this, in a GIS framework, in a GIS environment, can be represented by a point. So then we have line features. Obviously, we can easily associate line with some features such as rivers or, power lines or road networks. Line feature is simply points which are connected by a line. So we can have several points. When we connect these points with a line, so then we generate a line feature. So we have length, but we don't have area. Okay, so that's the other characteristic of line features. And lately, we have the polygon feature. And again, in our mind, it's very easy to understand how a polygon feature is generated. We have points, and these points are connected by lines. And when we close all these lines, we define an area. And obviously, polygon features are very good to represent areas such as, districts, municipalities, or whatever things have an area. I mean, let's look at a few examples, more visually or graphically. So, for example, this is an example of point feature. So then I have in my left-hand side, I have a map, a layer with a school. We have a label for every school, which is provided with a position, with a coordinate. And in the right-hand side, we have a map with village. We have the name of the village, and we have this yellow triangle, which basically represents the location of a school, of a village. For line features, again, it's very easy to understand how the line features can be used for. We can have river streams, streamways, we can have road networks. And obviously, line feature is the best way to represent this kind of feature. And the last one is polygon features. And again, this is an example of using polygons to represent administrative area and also to represent water bodies. So we have the Lake Victoria, part of the Lake Victoria in this western of Kenya, and the rest correspond to districts from Kenya. I think having that said, there is not a rule to tell you what type of features you should use to represent a feature of the real world. Let me explain myself. So, for example, this building that I'm seeing through my window can be represented as a point. But if, for example, I'm working on a final resolution, for example, I may want to know the area of this building. So then if I have the building delineated, this building in my GIS framework will be represented with a polygon, okay? So then the type of feature we are using to represent, features of the real world will depend on the spatial scale, the geographical, let's say zooming or zooming out. So how deeper we want to go in the area, okay? For example, another example is, using points for representing communities, or instead of, we can use, if we know the village boundaries, we can have a polygon, and then within this polygon, we can have points for the household, okay? So then you can understand that depending on, the geographical scale, we can use one type of feature or another to best represent what we need. And finally, this is an important feature, and you will learn how to handle this type of data, is the raster dataset. A raster dataset is no more than an image and a picture. So if you have a picture of yourself and zooming in the picture, you will see that the picture is made up of small pixels or cells, which basically have a regular size. So this size for the cell, basically gives you the space, the resolution of the image. So basically, a raster dataset is an image which is geo-positioned, geolocated. So then for every pixel, for every cell, we know the position of the centroid, of the center of this cell. Okay, we have a coordinate, we have X and Y, or latitude and longitude for every cell. And this allows us just to plot or to, let's say, display this raster in a GIS framework. Raster datasets are mostly used to represent continuous data. For example, elevation, precipitation, temperature, and also, as we can see in this example, land usage. In the left-hand side, I have an image where, it's a 300-meter resolution raster, where in every pixel we have information about what type of land cover we have. We have vegetation, we have croplands, we have water, we have urban areas in orange. So that's the way the raster dataset works. In the folder, you will learn how to get raster data, because it becomes a very important source of data that can complement your analysis, epidemiological analysis. As you have heard me, so I've been using, continuously, the terms of coordinate system, or X, Y, or position. Yes. So basically, as I explained, before, the point of the GIS is just to represent what we see in the real world. And in the real world, every element, every feature has a position in the space. This position is mostly defined by the X and Y coordinates, by the longitude and latitude, but sometimes we have a set coordinate which correspond to altitude with elevation. But it's not often that we use the set coordinates in this way. So we can use it if we have a raster dataset with elevation. We can know for a point what elevation there is at that point. So the other thing is we have two different types of coordinate systems. We have geographical and we have projected coordinate systems. They can be used for different purposes, and you need to understand in which condition and under which condition you should be using geographical or projected coordinate systems. So what a geographical coordinate system is, basically is probably the system more widely used. Basically is based on latitude and longitude coordinates, which are given in angle units, decimal degrees, minutes and seconds, and basically the position of any feature in the Earth is given by the latitude and longitude. Okay, so then we have this representation of the Earth, and every point is placed on this map, on this Earth, and has a latitude and longitude position. The latitude is defined as the angle between the equatorial plane and the line that passes from the north to south. So we can see in this way. So the latitude goes from north to south, and the angle that is defined with the parallel, nearest parallel, so gives us the latitude. And the longitude is basically the angle east or west from a meridian of reference. So we have the Greenwich meridian, which is the reference one. So then the longitude is going from east to west, and the angle that any parallel to the equator is defined against this meridian provide us with the longitude. Okay, so then this is for you to understand that geographical coordinate system, the units that we are using are given in angle units. But sometimes it's convenient just to have a different representation of the Earth. Sometimes it's more convenient just to simply open the Earth and place in a plane. Okay, so what we are doing when projecting a coordinate system is trying to move from angle units to a meter unit, so metric units. Okay, so then in that case, the latitude and longitude will no longer be given as angles, will be given in a metric unit, meters, kilometers, and they are defined as the XY, axis. And basically, we are measuring, the distance from every point to the nearest meridian or, parallel, but the distance will be given in meters. So then in the right-hand side, you can see, the same point just represented in a geographical coordinate system. We have in degrees the units, and in the right-hand side, we have the equivalent in a projected coordinate system that you can see is given in meters. So then I'm going to generate and simulate a GIS, how a GIS framework works in my PowerPoint. So then this is a very simple, I'm going to generate a basic simple base map, as I explained, using layers. So then first of all, I'm going to place a layer with the district boundaries. And at the top of this, I'm adding the river stream, the river network for this area. Then I'm adding the road network to this area. And I'm placing at the bottom of all these layers another with the land cover, which is basically provided as a raster dataset. Okay, so then we have the raster dataset. And, we have very quickly created our base map. And at the top of this, I'm adding, the location of the village in that area. So then let's go quickly through the last slide. So when to use GIS? GIS is mostly used to produce maps, obviously, but it's not the only, way to use a GIS project or to use GIS. We don't use GIS only to make maps. To be honest, in most of my times, when I am running a spatial analysis, I'm basically running many, processing in a GIS framework, but because it's more convenient, but not only because I want to generate a map. But yes, obviously, visualizing the spatial data is one of the main reasons to use GIS, but we can also use to generate new data. We'll use the GIS to run a spatial analysis and also to generate reports. Let's go quickly through the different types. One is, what do I mean by data generation? Okay, so when I, let's say, build up my map project, and it's something that you will learn in this course, you can, using your available spatial data, you can generate new data. For example, if I have a map or a layer with the health facilities, I may want to estimate the distance from every household in my study area or every community in my study area to the nearest health facility. So then in my GIS software, probably I will be provided with some tools to generate another layers which basically provide the distance from every point in my study area to the nearest health facility, or from every location of every household or community to the nearest health facility. So as I say, we can use to do data linkage. For example, if I want to run, let's say, a linear regression to explore for risk factors for a particular health outcomes, or yes, and I think that probably this outcome is associated with altitude, what I can do is I can plot my locations, my survey locations in my GIS project. I can load a raster data set with elevation, and I can extract for every location, I can extract the information concerning to elevation at each point. Then I can take this data set to my AP software, Stata, whatever you are using, and use this elevation for my linear regression, for example. You can also run some very simple spatial analysis in your GIS environment, and sometimes not simple. QGIS, as you will see, is a very powerful software. There are many functionalities that allow you to run complex spatial analysis within the GIS. So you can even run spatial pattern analysis in your GIS, as we will do the 5th day of the course. You can also estimate, for example, travel times, estimates and many other calculations. And obviously, visual display is an important bit when we are using GIS or when we are making maps. Obviously, for making a map, we need to understand like very basic principles. So why we generate maps? What is the purpose of the map that I'm making? So what type of things I want to highlight in my map? So what is the audience? I want to attract attention, and many other factors. So then you need to bear these things in mind when generating your maps, because sometimes, the way we are generating the map is differs depending on the audience or what is our intention with this map, etc. As I say, you need to think first. It's not just simply making a map for the good of making a map. You need to think what I want to show with this map. So I want to highlight the extremes. I want to highlight the average. I want to highlight some patterns. What I want to do. What colors and symbology I'm going to use is another important bit when I'm generating my map. For example, if in the map that I showed you before, I display the rivers in red, probably in a first glance, you will understand that these red lines correspond to rivers, because we tend to associate features with certain colors or certain, shades. So this is the kind of thing you need to bear in mind. What colors or symbology I'm going to use, to make the map more self-explanatory. Another bit you need to understand is large areas tend to attract more attention than the small. That's an important bit. So then if you, for example, want to stand out some, your outcomes for areas which are small, probably you need to add in like a small map insert where you will be zooming in your area of interest because you want to stand out of something that is happening at this small scale. I mean, this is the kind of thing you need to think about. And it's something that you will be learning as you will be practicing and working with GIS more and more and more. Yeah, let me very briefly show you how we use GIS in public health. So let's think about, the base map that I generated before. So then if we want to work to apply the GIS in public health, basically will simply mean adding new data to this geographic system, to this base map. We can add in demographic data. We can use data related to health coverage. We can add epidemiological data, obviously. We can add in environmental data. We can add in data concerning to water sanitation. So then basically these turn our, cartography in basically a health system. So we have a health GIS system in which we combine the basic cartography with outcomes which are related to public health or to health outcomes. For example, and obviously we can run a spatial analysis on this data for many purposes, for inferring new variables, to generate risk map, or just simply for public health management. For example, with health coverage, we want to understand how well, how well covered our population is based on where the facilities are located, what services these health facilities have, and we can estimate that, how many people, these health facilities are covering, or, how many or what communities or population is living more, far apart from the health facilities, and they require, other kind of assistance. So then going back to the example, so yeah, you learn how to generate your base map, but what happened when I add in, a health outcome? And in that case, for example, I add in data from a survey on soil transmitted helminth infection on ascaris. So then this is a prevalence survey, and we have now information about the prevalence of ascaris at community level. Probably everyone just very quickly, just looking at this map, may infer many things. So probably you can see a clear spatial pattern in how, the prevalence is distributed. You can also probably understand that, we have more, a higher prevalence in areas closer to the water bodies, but we can also see that, there seems to be a higher prevalence in areas with a land coverage, which is represented in yellow, which correspond to croplands, so then which are areas which are cultivated. I mean, just with this simple map, you can start understanding many things about your health problem. And finally, what we'll be using in this course or and during this practical, we'll be working with QGIS. As I explained before, it's open source software. I expect that at this time, most of you have managed to download and install QGIS in your computer. I recommended that everyone use the most, the most recent release version, which is stable, which is the Hanover version, the 3.16.5. I think there is a newer version, but it's not stable yet because there is still progress on this version. And this is why I recommend you all to download this one, the Hanover one. If anyone hasn't downloaded or installed QGIS, after this lecture, we can spend 5 minutes to guide you through the process to install QGIS in your computers. I'm not going to detain on this or spend so much time on this slide. So because when I guide the practice, I will show you what we have. But I think that there are probably, this is the appearance of the QGIS interface. In the point one that I'm pointing in one, we have the name of our map project. Every time that we work in a project, so we get or create a map project file. So the name of this map project file will appear at this. The second, point just is basically, or the box is pointing to what we call the menu bar. So then we have classified by different types. We have different functionalities. You will learn more about this menu bar during the course. What I want you to look at is the 7 and 4. So then the 7 is a browser. So you can explore your spatial data through the browser, and we will do it in later today. And another important one, because I will be using this name during the course, is the 4, which is the table of contents. Every time we are loading a layer to our map project, this layer will appear in this fourth panel, which is known as table of contents panel or layers panel. Okay, and the fifth is where we are generating our map composition. Today, basically, we'll focus on the principle or the basic on QGIS interface, how to start, manipulating and working with the spatial data. You will learn how to explore the layers properties and create a basic base map. So today is the basic. Tomorrow we'll give a step forward. So we'll start exploring epidemiological data. We'll be importing epidemiological data in our GIS framework and start exploring, the distribution of our outcomes. So we'll see and generate some maps, basically to show how these outcomes are distributed. And I mean, this another very basic step. During the third practical, we'll be doing some, exploratory and query analysis. Okay, how can I start, retrieving data or making queries on the data? If I want to extract spatial data for a particular area, I don't want to work for the entire country. I'm working on 2 or 3 districts or 3 regions, and I want just to generate my map based on spatial data for this region. You will learn how to manipulate spatial data and make queries. The fourth, and also, yes, in the third day, you will learn some basic geoprocessing tools. How to make joins, unions, how to make intersections, and how to generate buffers, these kind of things. Very, very basic. The fourth day of this GIS course, I will show you different sources of spatial data. So then I will have a lecture talking about different sources of spatial data. I will also presenting some sources of epidemiological data. There has been an increasing, availability of epidemiological and public health data. So then nowadays we have, sometimes you don't need to have the data. There are many resources from which you can retrieve the data. So you can get data, for example, in COVID, at different scale. We can have data concerning infection diseases or vector data. So there are many platforms. So we can get that information from this platform and use it in our project. And then we'll have a practical to show you how to basically handle raster data. Yeah, and I think we have finished with the lecture.